Hi, class. Last time we spoke about particle accelerators. And particle accelerators, as you recall, just work off of the idea that opposite charges attract and like charges repel. So you can use electromagnetism to accelerate particles. You can see this negatively charged balloon is speeding up and accelerating toward the positively charged particles. And so last time we spoke about, if we take a particle, let's say a positively charged particle, and there's a negatively charged, let's say, tube near it, it will accelerate towards that tube. And then if at just the right moment in time, we make this tube negatively charged and this tube positively charged, well, it will be repelled then by this tube and attracted by this tube. So it would continue its journey down the tube, getting faster and faster the whole time through. And this is what we call a straight line or linear accelerator. So that's what might be called a LINAC. Today I just want to show you the largest particle accelerator in the world, which is called the Large Hadron Collider. It's located in Europe, so it's over in Switzerland, and it is very large. If you look at this picture down here, let me show you a different view of that. If you look at this picture down here, you can see mountains in the background here, and this circular pathway is the particle accelerator. So it says 27 kilometers down here. That's about 20 miles in circumference to go around it. And it's not a straight line. This is not what's called a linear accelerator. This is a circular accelerator. And what they do is they start off with they take charged particles. They start off with a linear accelerator, which is a straight line acceleration, and they put it through a small circular accelerator. It gets faster and faster and faster. Then it spits into a bigger accelerator. If you can see this blue circle down here, it gets faster and faster and faster. Then they put it into the big, giant 20-mile loop here, and it gets faster and faster and faster. And then they smash the particles together. So there's actually two sets of charged particles. One set is going clockwise around the circle, and the other set of particles is going counterclockwise around the circle. And then in a couple of areas, they have what's called detectors, where they can steer those two beams together and smash them together. So there's a detector over here. This one's called Alice. There's a detector over here. That one's called CMS. There's another detector over here. And this thing is so big, and actually part of it is in France, and part of it is in Switzerland. So you can see that here's the border between France and Switzerland right here, this dashed line. So it is a very, very big particle accelerator. And I'll just show you, I'm going to attach these videos, but I'll just show you some pictures of what it looks like inside. This is the tube that takes that's about 20 miles long. And you can see and then when this is one of the detectors, which are very, very large, and what they do is they smash the particles together, and look what comes out. And they use the detectors to see that. So that's basically the idea, but it's very, very large, and they accelerate the particles to very, very fast speeds. This is a picture of one of the detectors. And if you went down from the bottom of this detector to the top of this detector, it's about the distance from the basement of Lehman High School to the top of the 4th floor of Lehman High School. So this down here might be the basement, and then this might be around the 1st floor, and the 2nd floor, and the 3rd floor, and the 4th floor would be up here towards the top. So these detectors are very, very large. Let me just show you a couple pictures. And so again, here it's really, really long. You've got these tubes that the particles are going down. There's really two tubes inside of here. One is carrying particles that are traveling this way off into the distance, and a second tube is carrying particles that are traveling in the opposite direction. So particles are going, one set of particles is going that way, and another set of particles is going this way. The rest of the stuff is for cooling and electrifying magnets and things that keep the particles where they need to be. And then this is a picture of the detectors. They've got it open for maintenance, but you can see the little tube down here. This is where the particles are going to be coming in. There's a couple of tubes, and they merge them together into one tube so that the particles will collide. And then this big thing over here is effectively a big sensor that can detect the little things that come out. And so this giant machine called the Large Hadron Collider, it's the world's largest particle accelerator and particle collider, and it is used to just try to figure out what what is inside of atoms. What are atoms made of? All right. And just a couple of little details. So I'm going to give you a couple of videos to watch and then a couple of questions to answer. But it's important to know about this particular machine. It is the world's largest particle accelerator and super collider. So CERN, the CERN LHC is a particle accelerator. It can only accelerate charged particles, so it can accelerate things like protons and electrons. If it's not charged, it can't be accelerated. So it cannot be used to charge things that do not have a charge, such as neutrons. Right? So we think of all the models of the atom that we've spoken about thus far have protons and electrons, and there's also neutrons in the nucleus, which are neutrally charged. They do not have a charge on them. So the particle accelerator could accelerate protons and electrons, but it could not accelerate neutrons because they don't have a charge. So the accelerator can only accelerate charged particles. As you'll see in the videos, it will accelerate particles to right up just about the speed of light, and the speed of light is 300 million meters per second. So these charged particles are whipping around that big circle at about 300 million meters per second. And one thing that they're going to discuss in the videos is once the particles get close to the speed of light and they keep adding more energy to get them to what we normally think of as you keep pushing them, as you keep applying a force to them, they will continue to accelerate and they will continue to get faster. But there is a limit, and things cannot get any faster than the speed of light. And so what happens is once you get close to the speed of light, as more energy is added to try and speed up the particles even faster, the particles don't actually get any faster, but instead they get heavier, they gain mass. So it's just something you're going to hear in the video, that once you get very close to the speed of light, as you add more and more energy, the result is not greater and greater speed, it's more mass. You can think of it as more heaviness of the particle. So the particles gain mass instead of gaining speed once they are close to the speed of light and you continue to add energy. All right, so you'll see that in the attached videos, but take a look there. You should know about this machine. It's one of the most important and large-scale machines that has been built for physics research, and it's a very well-known machine, and hopefully you'll find it interesting. Okay, so watch the two attached videos as well as this one, which you just watched, and then answer the questions on the attached quiz form. All right, thank you.